This lesson deals with supplemental problem 312. You can find this problem in the ECE302 ebook in the Chapter 3 Supplemental Problems on page 17. Given this one transistor PNP circuit with two power supplies and two resistors, could you find the current I and the voltage V if the emitter base turn-on voltage is 0.7 volts, the emitter collector saturation voltage is 0.2 volts, and beta F is 100? Take a guess at the state of Q1, and then check your guess, and if necessary, guess again. In most circuits, current wants to flow from the most positive power supply to the most negative power supply. Current's going to want to flow in this direction. The current coming into the emitter and the current coming out of the collector are both going to be positive, and the voltage across here is 5 volts minus a minus 15, or 20 volts. A drop across here, a drop across here, and a drop across here. That's to add up to 20. This is probably bigger than 0.2, given that these are just 1K resistors. So I'm going to guess that this is probably in the active region. The first step is to put in the model. I have a 5 volt source to ground. I have a 1K resistor. I have a 1K resistor back to a minus 15 to ground. And then between the emitter and the base, I have the turn-on voltage of 0.7. And between the emitter and the collector, I have a current source of beta FIB. Let me scroll this up a little bit. My collector, my base, and my emitter current, my collector current, the voltage V, the current I, and my base current coming out of the base. We need to show that the base current is greater than or equal to 0 and that the emitter collector voltage is greater than or equal to 0.2 volts. Let's solve for this emitter current. It's the current in this resistor, which is between two node voltages. 5 minus 0.7 divided by 1K would be 4.3 milliamps, and that's my emitter current. In the active region, the collector current is the emitter current times beta F over beta F plus 1. In other words, the collector current is a little bit smaller than the emitter current. In this case, it's 4.26 milliamps. And then the base current is just simply the collector current divided by beta F. Dividing this by 100, I get 42.6 microamps. Is that greater than or equal to 0? Yeah, so that checks. The emitter collector voltage is here. It's going to be this node voltage of 0.7 minus this node voltage, which is I sub C times 1K minus 15. This node voltage minus this node voltage, plugging in that this is 4.26 milliamps times 1K, the milli and the K's cancel, and I get 4.26 volts. And all of this is 11.4 volts, and that is greater than or equal to 0.2 volts, so that checks. We are in the active region. We can now solve for V and I. V is the voltage here, so the rise in voltage would equal the drops around the loop. I sub C times 1K minus 15, and that's 4.3 minus 15, or minus 10.7. And the current I here is the collector current, and that was 4.26 milliamps. This is supplemental problem 312.